Hi there, Prof here. Welcome to C++ 101. This is the fifth episode, and in this episode, I'm going to talk about basic input and output operations in C++. If you haven't watched my previous tutorial, then please do so now because this is a continuation of the previous episode. Okay, let's get started. We have come across cout many times so far, and at least you know that whenever we want to display something on the screen, you do so or we do so with the cout object. C++ uses an abstraction called streams to perform input and output operations in a sequential media such as a screen, a keyboard, or a file. A stream in C++ is an entity where a program can either insert or extract characters to or from. C++ standard library defines the following stream objects that are used for standard input and output operations. We have cin, which is the standard input stream, cout, which is the standard output stream, then cerr, which is the standard error output stream, and clog, which is also the standard logging output stream. cerr and clog are special purpose output streams for error messages and logging respectively. However, in most environments, they actually do the same thing as print on screen, although they can be redirected to print elsewhere. Now, cout is used together with the insertion operator, which is written as the double less than sign over here. The insertion operator inserts data that follows it. So in this case, our hello world into the stream that precedes it. So the stream here is cout. Now, one thing you should take note is that in C++, always whenever we are inserting into a stream, this is the operator we are going to use. So although we have three different stream objects here, we are using the same the same insertion operator, and it is the same thing we will use for file streams and even string streams. Okay, so let's go ahead and run this program and see what happens. So you can see that all the three streams, cout, cerr, and clog, they are all printing to the screen because that is the default state of it on my operating system. But I can actually redirect it to print to whatever or wherever I want. Instead of writing individual cout statements as we have here, so we have int yob 1990 and we have multiple cout statements here. Okay, instead of writing this on different lines, we can actually put them together and on one line. Okay, we can chain them together using the insertion operator. Now let's take a look at the results for this one. So we have my name is Professor, I am 29 years old. Okay, so how come we wrote all these on different lines yet we had all of them on one line? The trick is that we never inserted any new line character inside or after this printout statement with the exception of the final one. Okay, now instead of doing this, we can equivalently or equally do this and forget about the multiple cout statements and use just one. Okay, now this is equivalent to this, and I think this is preferred. Now if we run it, you realize that the result is the same. Oh, except the fact that I forgot to insert a space at this end. Now, in most computing environments, the standard input is the keyboard. In C++, you can access the keyboard with the cin stream. Cin is the acronym for character input and cout is character output. Now, cin is used together with the extraction operator. So look at the difference. One is pointing to the right and the other is pointing to the left. To the left is the insertion operator which works with output operations, and the one that points to the right is the extraction operator, which works with inputs. Okay, so the extraction operator is made up of double greater than sign. As I said in the past episode, I have seen a lot of newbies who often get confused about when to use the extraction operator and when to use the insertion operator, but it eventually becomes okay. But in the beginning, yeah, they kind of fumble a bit. Before you can read or extract data from the keyboard, you will need a variable to read into. So every time you are going to see a variable declaration whenever a cin operation is carried out. It is like going to the riverside to fetch water. You can't walk to the riverside without a container to pour the water inside. Okay, so every time before we perform any cin operation or data input operation, you would see a variable being created to store whatever we are storing, we are reading. Cin is smart enough to know the type of data by looking at the variable to save into. Okay, so all we have to do is create a variable and put the variable here. Cin will actually know the kind of data it's supposed to read, and in this case, because we have an integer data type, cin would be expecting an integer, and if it doesn't find an integer or something that can be converted into an integer, it will throw an error. Later on, we will look at how to make use of this code to detect whether a read operation was successful or not. Creating a variable for the storage is not enough, because what happens is, let's take a look at this code. If I comment out this printout statement and run this, you see what is happening? We just have a blinking cursor. Now at this point, the user is waiting for the program to do something, and the program is waiting for the user to type something. Okay, so if I type something, fine, the program continues execution. Okay, now it is not a good idea. So what we do is that before you make any request for data input using the keyboard, you have to give a small printout statement to inform the user what to do. This printout statement is called a prompt line, and it is very important in this kind of terminal based applications. Just like the insertion operator, instead of writing multiple cin statements on different lines, we can actually daisy chain them in a single statement like this one. So here we have we need 3 year of birth, YOB1, YOB2, YOB3, and we want the user to enter all these values. But then, instead of writing 3 cin lines, we are actually chaining them together. And what is going to happen is that the first value that will be typed will be recorded and saved in that. The second one will be saved in that, and the third one will be saved in that. And this is another thing that comes in very handy when you are writing very complex applications. We've said enough about this input and output object. Now let's look at a sample program. Let's put this into action. Okay, so let's say we want to design a simple program that takes as input the year of birth of a person or the user and calculates his age or her age. Now, first of all, we need a container to store the year of birth, okay, when we take it from the user. So we have to start by declaring a variable. However, remember, you don't just go about creating variables. Before you create a variable, you should know how much space you need for it to be stored in and the kind of operation that should be carried on it. And this information is encoded in the data type. Now, let's look at the data we want to take. Year of birth. Typically, year of birth is a 4-digit number. And so that means it can be saved as a character data type because that will limit us to 255. So the next best option is a short int data type. So the first thing we are going to do is create a variable of type shortend, and we will call it YOB, which stands for year of birth. Now, one thing that I think I said in the previous episode is that always try to make your variable names descriptive, okay, so that you are kind of documenting your code whilst coding. You don't have to use things like X, K, M. Later on, when you come to pick your source code, you'll be wondering why or what the S and the K's are doing. So please always use very nice names that are very descriptive, not too long, easy to remember, because chances are that as your program becomes large and you forget almost all your variable names, you always have to be scrolling up and down to search for the variable name. So make your variable names very simple and very descriptive and easy to remember. Alright, so the first thing we will do is to create the container, which is the variable. Okay. To calculate age, we have to know the current year. We are in 2019 as at the time of recording this video. So let us save this information inside the memory. But wait, for this information, we don't want it to change until we probably get to next year and we come back to our source code and change it and recompile. Let's assume that. Now, to ensure that the compiler prevents any changes to this value, we will add the const modifier to it. So the next thing to do is to create a variable to hold our current year, which is 2019, and we have this little const keyword to ensure that this value can actually not change. Now we have to give the user a prompt so that he or she will know what to do. So let's do that. We insert a simple CR statement that says that enter year of birth. Okay, so when the user enters the data, we have to read it into the variable using the cin. So the next line of code is to use the cin object to read the data and save it into our year of birth. Now that we have the data, we can go ahead and process it and give the result or display the result on the screen. We could calculate the result and save it into another variable, but we don't actually need that because we don't need that information for any further processing. Okay, remember, if you don't need to use memory, then don't use it. Okay, so instead of storing the result in another variable, what we are going to do is put it in an output statement and just display it on the screen. And that is all we have to do. So that is the next line of code. So we have cout UR, then we perform the calculation by subtracting the year of birth of the user from the current year and add years old to it. Now let's run the code and see. So enter year of birth. Now if I enter 2000, hit enter, hey, you are 19 years old. Let's run it for the second time. This time I'm going to put 2018 and it says that hey, you are 1 year old. Forget about grammar. Now, so we know that the program is working. So you see how simple the whole thing is? That is all we have to do. It is not rocket science, okay? If you want to write programming, want to do good programming, understand the algorithm, have a plan, and know how to use your underlining language to execute the task. Alright, I hope this helps. Thank you for watching. If you are interested in electronics, then please check out my Electronics 101 tutorials on this same channel. Don't forget to give us a like and share and subscribe to this channel. I am Prof and this is Tech Foundation Africa.